Hello, welcome back to Shakir's physics classes. Previous class we have stopped at relation between electric potential and intensity. We derived an expression E vector is equal to minus del V. We saw the significance of that expression. Hope that was clear to you. We move on to the next topic for discussion. The topic for discussion today is potential of a charged spherical conductor. Spherical conductor. Let me first draw the diagram. Okay, it looks like a circle, a sphere. We will try to draw it. Let us say this is the center. Center is O. Okay. Okay, this is X, this point is P, let this be R and N. I will try to explain to you what the diagram is, what are we actually interested in, etc. Okay, fine. We consider a point P outside this hollow spherical conductor whose radius is A, center is O. In other words, I am considering a spherical conductor of radius A, center O. A point P lies outside this spherical conductor at a distance r from the center O. We are interested in finding out what is the value of potential at this external point P. I say it is an external point P because it's not lying on the spherical conductor but lies outside the spherical conductor. In order to determine the potential due to this spherical conductor, let us consider two neighboring points A and B on the surface of the sphere such that angle AOP is equal to theta and angle BOP is equal to theta plus del theta. All these things I have told you only for the diagram. Okay. We know the expression for potential just in the previous class we derived. V is equal to 1 upon 4 pi epsilon naught Q upon R. For the sake of better understanding, I will write that expression somewhere here. We know potential at a point due to a point charge as 4 pi epsilon naught. We are going to use this expression basically. That's the reason why I have written it here. Now sir, if you consider these 2 points A and B, I have drawn lines. If I cut, I will get a strip of this much thickness. You understand what I am saying? I am considering as a thin element. My first step is I have to find out what will be the surface area of this filament before I go into it. I have written sigma here. What is sigma? Sigma is surface charge density. When I say surface charge density, I mean it is charge upon unit area. Charge upon unit area. I need to even clarify that because I just now told you, let me find out what is the surface area of the filament. How do I do that? This if I cut, I will get a strip. Therefore first I have to find out its radius. If I find out its radius, I can find out what is the circumference. With the circumference, if I multiply its thickness, I will get surface area of the element. Therefore, I write surface area of the element. Is that okay to you, sir? Now, the radius of the sphere is A. The radius of the element will certainly not be A, it will be something else. How do I find out that? This one I want, this one. Let me take sin theta, opposite side. Why? From anywhere, from the center you draw a line, it will be radius A. Which means my opposite side will be A sin theta. Therefore, I will write my surface area as 2 pi A sin theta. This will give me the circumference of the element into its thickness. This width I want. If you look, this portion AB looks like an arc. If A is the radius and the angle subtended is del T, A into del theta will give me the thickness and this length. Therefore, circumference into A del theta will give you surface area of the element. Finish. As simple as that. As simple as that. My next step is, having determined what is the surface area of this element, I can as well find what is its charge. What is the charge? Charge of this element. See, sigma can be written as Q by A. Therefore, Q is equal to sigma into A. Here A is area. In our case, it is the surface area of the element. Therefore, with this expression, if I multiply sigma I will get what is the charge of the ring. Therefore, charge on the ring. This is equal to, am I right? 2 pi a square sin theta, okay, into del theta into sigma. This will give me what is the charge on the element. Charge on the ring or charge on the element, in whichever way you want. And you can see this element is at a distance x from the external point P. So what I am going to do is, first I am going to write an expression using this for potential at the point P due to this small element. Therefore I say, if dV is the potential at due to the ring at P, I will write dV instead of, because it is a small element, the small potential due to this element in the point P. That's what I mean. 1 by 4 pi epsilon naught Q. This is the charge. 2 pi a square sin theta del theta into sigma upon r. The distance is x, therefore I write it as x. Is that clear to you, sir? If this is clear to you, I need to go to the next step. The problem is, I want to determine potential at P due to, not due to this ring alone, but due to the entire spherical conductor. At what distance? At a distance r. You can see there is no r here. So I cannot use this like this. I am going to change x in terms of r. How do I do that? How do I do that? How do I do that? For that, I am going to draw this diagram again. Okay? See, this part I am taking. For your sake, I am drawing this. This what I take. Okay? I will write the names. This is A. This is the center point O. This is P. This is R. This is X. Let me drop a perpendicular. I am dropping a perpendicular here. Okay? This angle is theta. Let me write as theta. Let me write as B. This is not this B. Some B I written here. Okay? Right. Now, geometry of this can be written as, supposing I want AP square. AP square. This is equal to OP square plus OA squared minus 2OP into OB. This is basic geometry. You are not in a position to understand this. Please flip through pages of 10th standard geometry. That's there. Okay. Let me now substitute, sir. AP is x squared. OP is r squared. OA is radius minus 2. OP is r. Am I right? OP is R. OP is R. Yes. I do not know what is OB. I do not know what is OB. This is adjacent to theta. Therefore, let me take cos theta. OB by radius A. OB is A cos theta. Therefore, I write A cos theta. I suppose you have understood this. Fine. In my expression, there is an x. What I am going to do is, I am going to do something with this expression to get the value of x. What do I need to do? Somebody will say, sir, take the square root of it. Fine. If I take the square root of this, certainly I am going to get x. I am not going to do that. Instead, I am going to differentiate this expression with respect to x. Differentiating with respect to x. Okay. I get 2x dx is equal to constant 0, 2 r a cos theta if you differentiate minus sin theta del theta. Finish. Is that okay to you, sir? Minus 2ar sin theta del theta. From this I will determine x. X will be equal to minus, if I differentiate cos theta, it's not minus sin theta, it's plus sin theta. I'm sorry. Therefore, this is going to give me a r sin theta del theta divided by dx. Is that clear to you? Minus, if you differentiate cos theta is sin theta. If you differentiate sin theta minus cos theta. Okay? Now, I am going to rub this off. The diagram I read a little bit later. Therefore, I will rub this part off to continue. Okay? Let me substitute this value of x here. Therefore, I get dv is equal to 1 by 4 pi epsilon naught 2 pi